OK. Ladies and gentlemen, so now I'll go ahead and get to this one. So now what I'm going to do is, I'm sorry, there wasn't one more example I want to do. But now, rather than multiplying, in the first two examples, we multiplied a monomial times an expression. Now we're going to be multiplying an expression times another expression, basically a binomial times a binomial. Now you can see that in each of these expressions, though, they are separated by addition or subtraction. That's very important to understand, because now what we have to do is apply distributive property with each of these terms. So now I have to multiply both of the terms in that expression by both of the terms in the other expression. Some of you guys probably remember that an easier way that we kind of talked about this was by using FOIL. And basically, FOIL is the same thing as distributive property. It's just a nice, easy way to kind of remember it. And basically, the way that FOIL went was multiply the first two terms first, then multiply the outer two terms, then multiply the inner terms, and then you multiply the last terms. So if you've learned FOIL before, that's great. If you just want to remember the distributive property, that's great as well. However, for both of these terms, whenever I'm multiplying, I prefer to actually look at it in a different way. And the reason why I'm going to look at it in a different way is because what we're going to be getting ourselves into coming up in the next chapter. So if you guys look at a box or a rectangle, and I say I want to figure out what is the area, hopefully you guys remember that area can be represented by multiplying length times width, correct? So basically, understanding that the product of two terms or expressions is going to be represented by the area. All right? The product is representing the area of two dimensions. So basically, in this example here, we are multiplying really we're multiplying two expressions. So therefore, the product of these represents the area. So I can use a box to represent the area of that. The only thing I need to understand is one of these expressions is length, one of these expressions is width. Now, since each expression has two terms, I'm going to create two columns and two rows. And I'm going to put one term in each row and column. So now, rather than doing all of the figuring out which one I have to multiply first, doing first, outer, inner, last, now all I can do is break this down and just do the math, just find the area, the length, and the width for each box, and find the area. So the length of this one is x. The width of this one is x. So x times x gives you x squared. Over here, here is my width. Here is my length. X times -2 is going to give you a -2x. Here, x is my width. 3 is my height. 3 times x is 3x. And here, my length is 3. Here, my width is -2. 3 times -2 is -6. So what's nice about this is I want you guys to understand this represents the area of this box. Also, it organizes them into separate boxes. And we see that like terms can also be combined here on the diagonal, as long as you write your binomials in descending order, which we'll talk more about, but with always the variable first, and then going with the highest power first, and then going down. What you guys can see is I can combine these. 3x minus 2x can combine to x. So my final answer is x squared plus x minus 6. And that is your final answer. Otherwise, if you were to multiply this out, you're going to have now 4 terms of all these products, and then you have to combine like terms and then organize them. But in this way, you can just you can combine what you need to combine and then write out your solution. OK? Yes? It's very similar to just like a Punnett square. Exactly.